Hello, thank you for joining today's webinar, A Holistic Approach Solves Infiltration in Naperville, Illinois. My name is Luke Lagos, editor of Municipal Sewer and Water magazine. This is the first webinar hosted by MSW, and I'm excited to be part of this educational hour intended to help you make informed decisions about controlling infiltration and sustaining your wastewater collection systems. Here are my recommendations for getting the most out of the next hour. Our main objective is to discuss a rehabilitation project in Naperville, Illinois. You'll hear directly from a city official and contractor as they highlight background events leading up to the project, details of project execution, and open discussion on the outcomes. The platform we're using has all participants on mute, but it's important we get interactive, and here's how. The last 10 minutes are reserved for your questions submitted online. I recommend as questions come to mind, type them into the collapsible dialog box to the right of your screen. If we don't get to all the questions on this webcast, we'll answer every question individually by email. You'll also be able to interact through our poll questions. These are interesting because we'll play back the answers right away, and you can see how your opinions stack up with your contemporaries. Before we do our first poll question, I'd like to introduce you to our subject matter experts. Tony Conn is Supervisor of Collections and Pumping for the City of Naperville's Department of Utilities. With 24 years of experience, Tony has more certifications than I can rattle off, but I assure you he is a voice of authority. John Manijak is a project manager with 15 years of experience at National Power Routing, better known as NPR, a Carlyon company. He is a member of NASCO, ICGA, APWA, IWEA, and the Water Environment Federation. Don Rigby is Vice President of Marketing and Education at Avanti International. He serves NASCO and ICGA in leadership roles, is active on the WEP Collections Committee, and takes every opportunity to evangelize the effective use and longevity of injection grouting. So let's do the first poll question right now. I'll ask Jessica Williams, also with Avanti, to assist. Jessica?
Thank you, Luke. On the screen, you should be seeing the first poll question. What is the principal cause of underground infrastructure decay? Lack of maintenance, erosion, infiltration, exfiltration, H2S gases, or all of the above? Please indicate your single best answer to this question, and in moments I'll display and review the results to all.
Now closing and sharing.
Okay, kind of what I figured. Most people said all of the above, 72%. Now I'll turn the presentation over to Don Rigby.
Thank you, Jessica. And Luke, grateful to you and MSW for hosting this live learning event. We're about to tackle a pretty complex issue, but by design, my role in this broadcast is pretty simple. Tony and John have something very meaningful to say about their battles against infiltration, but my role is to elaborate on why. Why is infiltration an important topic, and what are its consequences? And what choices do we have to solve this problem? Injection grouting's been around. It's been one of many tools in the toolbox. It's been around for 50 years, and municipalities have been grouting for that long period of time with mixed results. And here's why. The first decade, beginning in mid-60s, municipal grouting was largely exploratory. You know, I've had the opportunity to interview many of these early pioneers, and their stories sound very similar to other industries in their early infancy stage. And they were responsible for...
We are not seeing your screen.
Is that right?
There we go.
Sorry about that. As I was saying, in the early days, I got to talk to many of these early pioneers, and they shared many of the same stories as other industries in early stage, but they were a catalyst for many of the technology advances we depend on today, including CCTV, pumps, packers, and of course, grout chemistry. The next 3 decades I affectionately refer to as Wild Wild West days. There were no industry standards, largely contractor-driven, and success stories were fairly inconsistent. And many of these current opinions and beliefs about grouting stem from this period, which is understandable and very difficult to change. In the last decade, we saw the introduction of standards. performance standards from ASTM, operating standards from NASCO, which advance the practice to far more predictable outcomes, and the vendor community has done well to teach these standards and preach their importance in everyday operations through Grout schools and white papers and such. The current decade, if I could use a single word, I would say quality is the one word that defines how the grouting community has changed so much today, much different than previous decades. There's a greater focus on science, new rules for contractors for injecting for longevity, and yes, there are certification programs on the horizons for inspectors and operators to make certain the value engineering elements of the specifications are followed to the highest degree. So what's driving this momentum? Need is a driver. Demand is a driver. I&I is the reason half the flow to the treatment facility is clean groundwater. Not only is this higher expense to the ratepayer, but it's also a contributing factor to the decay of underground assets, reducing the useful life of expectancy of our collection system. In addition to unwelcome groundwater, infiltration ushers in soil fines, reducing capacity and adding municipal expense for jetting and cleaning the system. Following a rain event, infiltration exasperates conditions for sanitary system overflows, and nothing captures the attention of EPA greater than SSOs. Relative to the customer and ratepayer, basement backups are a public relations challenge for every municipal authority, and the public is deserving of a safe community. Sinkholes are often the result of lack of maintenance of our underground utilities. Clearly, infiltration is the enemy. So what are we doing to maintain, repair, and remediating infrastructure? Every day, I wake up grateful that these technologies exist. These are necessary and important technologies. And they all have one thing in common. They are structural. And they are also expensive. Injection grouting is non-structural, generally speaking 25% of the cost of lining. Grouting is complementary technology to lining versus a competing alternative. Your condition assessment guides you to an execution plan that may include both lining and grouting. And for structural rehab, line is necessary. And if 80% of your defects are infiltration problems, injection grouting is engineered specifically to stop infiltration. And grouting is the only technology that stops infiltration at all 4 points of entry. To beat infiltration, a holistic approach targeting all 4 points of entry is required. And that includes manholes, main lines, laterals, and lateral connections. This is exactly the wisdom you're about to hear from our next two presenters. And with that, I'll turn this presentation over to Tony, who spent most of his professional life, fighting the effects of infiltration. So Tony Conn, thank you for being here and telling your story. And I am going to make you presenter here in one moment. How about now? There you go.
Thank you, Don. Good afternoon, everyone. As Don said, my name is Tony Conn. I'm the Wastewater Collection Pumping Supervisor for the City of Naperville's Department of Public Utilities. And I'm just going to go over a quick overview of the City of Naperville. We're about a population of 145,000 plus. We're about 30 miles west of the city of Chicago. With about 154 miles of sanitary sewer and just under 42,000 customers, we have one wastewater treatment plant, and we also treat the wastewater from one satellite community. Just a quick review over sanitary sewer rehab work that's been done in the city of Naperville. Manhole rehab time frame. We started in the late 80s with doing manhole renew. That is a poured in place manhole process. And then in the mid 90s, we started using permacast. That's a spun-in-place manhole process. Both of these processes were done in-house. And then about 2001 to current, we started using Spray Rock, Raven 405, cured-in-place manhole liners, and Spectra Shield. These processes are used when the entire manhole needs to be redone, and they're also outsourced to licensed contractors. If there's only an issue with the upper structure, in the city of Naperville, we use LMK's cured-in-place chimney liner, and that work is done in-house. Mainline lining. Mainline lining we've done started in the early 90s. We use many different types of linings, inverted, cured-in-place, fold-in-form, pulled-in-place liners, and recently we just did several demos with ultraviolet cured-in-place pipe, which is a great product. It's just the issue that we're having in this Chicagoland area is there's a lack of installers for the UV cured-in-place process. Lateral lining. We began lateral lining in the early 2000s. Before that, we were doing open cut and pipe bursting in-house for our lateral rehab work. Currently, city crews locate laterals 18 foot onto the private property, and then city crews install a vacuum at that location. At that point, the laterals are lined with LMK's T-liner, and we go from the main line all the way to where the cleanout is installed. This is done two reasons: to get away from any storm sewer crossings, and to try to get the rehab work out of the groundwater table if possible. In Naperville, we began mainline grouting back in the early 90s because of the large lining projects that we had going on. The grouting got pushed back a little bit. The largest pipe done to date is a 36 reinforced concrete interceptor, and this was done as part of a lining project to stop water migration and to prevent resin washout when the liner was installed. Lateral grouting, test and seal of lateral connections started around 1999 with just the first 4 to 5 feet being grouted, and including the mainline connection. This was also pushed back due to our large lateral lining program back in early 2000s. All of the services that we grouted have been checked several times over the last several years, only under saturated ground conditions, and I could happily say that every single one of them that we grouted show no signs of leaking. Manhole grouting. Manhole grouting is done in-house with city crews. We've used many different makes and types of grouts, like urethanes and acrylamides, and sometimes both on the same manhole, depending on what the situation. And we've had some very great success with our manhole grouting process. Sewer basin renew. After 2001 rain event, we started looking at a better way of doing our sewer rehab work. During this rain event is when we really started noticing the issue with water migration. This is when we started rehabbing an entire flow basin instead of just jumping around fixing the worst leaks. After rehabbing the entire flow basin is when we really started to notice true flow reductions. During a heavy rain event in April 2013, Naperville had about 7.48 inches of rain in a 48-hour period, resulting in a lot of flooding, a lot of street closures, some basement backups. After reviewing areas of all the backups where we had customer service calls, what our flow monitor data was, and what our groundwater data, we prioritized some of our I&I rehab efforts to the Crest Creek area, which is the area that we're really focusing on in this presentation. After televising over 58,000 feet of sanitary sewer main lines, inspecting and locating 450 laterals, and inspecting 355 manholes, it was decided that the rehab of the main lines, manholes, and laterals was needed. Problem being that the groundwater level was too heavy. All the groundwater leaks were too heavy just to line everything. Leaks had to be stopped first to prevent resin washout when we were installing our new cured-in-place liners and before the manhole rehab process could be used. We decided to grout the main line joints. We grouted the lateral connections and laterals as far up the service as possible. We originally wanted to go 80 feet up the lateral, but we ended up having to settle for 38 feet up the lateral. At the time in the Crest Creek area, only the 24 and 27-inch interceptor and its manholes were rehabbed. Problem with the Crest Creek area, the groundwater table in this area is always high, and the sanitary sewer mains and the laterals are constantly underground under the groundwater table. Some slides of overland flooding during the 2013 rain event, and more flooding of the 2013 rain event in the Crest Creek area. Water migration. After many years of our sewer rehab work, we noticed high flows, still getting high flows during heavy rain events. After lining mains for many years, we began televising this work under saturated ground conditions. We noticed how the water was actually migrating between the hose pipe and the liner and coming out where the service connections are reinstated, and also noticing where the termination points of the manholes, we had water migrating to there. During one of our large interceptor lining projects, you can actually see the groundwater table changing. The colors of the manholes were getting darker. Manholes started to leak. Service laterals that never leaked before started to leak. The water just migrated to all these defects. This is when we decided to start grouting main lines before we were doing cured in place installs to stop the water migration between the hose pipe and the liner. Rehabbing the whole basin, the mains, the manholes, and laterals to control the water migration is where we actually started noticing, again, true flow reductions. Back to the manhole terminations, we also started using Insignia end seals and also Secador 31, both of these processes to seal the area between the hose pipe and the liner at the manhole terminations. These pictures show groundwater leaks between the hose pipe and the liner at every service reinstatement. The photograph to the left shows water migrating and leaking between the hose pipe and the liner at the top of the service connection and the bottom. And the photograph to the right shows the groundwater leak in between the hose pipe and the liner at the top of the service connection. This photograph is just another photograph of a service reinstatement that is leaking in between the hose pipe and the liner. It actually looks like a high pressure hose blowing through. And then the scope of work in Crest Creek, the city of Naperville lined with cured in place pipe over 57,000 feet of main lines and rehabbed 349 manholes with the Spectra Shield lining system. The last 6 are being done under the current manhole rehab contract with Raven 250 mils of Raven 405. These laterals will be grouted to stop groundwater leaks in 4 phases. Laterals are not being lined at this time because our service line lateral program is already committed to other areas, and the groundwater leaks, these leaks have to be stopped before we can line these laterals, or we're going to have resin washout. Part of the Crest Creek, we grouted, first grouted using about 2,500 feet of 12-inch clay pipe and 56 laterals. This was done for several reasons. To seal the main line joints to minimize resin washout when we installed the cure in place liner. If you have resin washout, obviously you're going to have soft spots and the liner is going to fail. Another reason is to stop groundwater infiltration between the hose pipe and the liner. To prevent groundwater from backing up into basements when the cured in place liner was installed. That was a huge concern. We didn't want any basement backups with clear groundwater while we're trying to rehab the sewer line. And another reason was to minimize bypass pumping. The goals were to prevent any future wastewater backups during a heavy rainfall event, to reduce I&I to the flows to a downstream pump station, improve the life of our sanitary sewer system, and improve the performance of our sanitary sewer system, and of course, reduction of I&I. Current results, this is an area that was grouted used with cured in place and grouting, comparing June of 2013 flows to June of 2015 flows, which happened to be the wettest June in Illinois history. You'll notice that we had 2.2 more inches of rain in 2015 than we had in 13. Our groundwater level was 4.3 feet higher in 15 than it was in 13. But in 2015, our average daily flow from this basin was down 320,000 gallons. That's the average daily flow, and we had 0 wastewater backups, again, during the wettest June in Illinois history. This is another graph showing flow reduction of an area where the entire flow basin was rehabbed using cured in place on mains and laterals, Grout and Raven 405 on manholes. Between 1999 and 2011, flow comparison, our flows have gone down 760,000 gallons on an average daily flow. This graph is showing citywide flow reductions. It's showing how the city of Naperville's population has gone up, but the flows to the treatment plant have continued to go down, comparing our 2000 flows to our 2014 flows. And with that, I would like to pass on this part of the presentation to John Manijak of National Power Routing.
Thanks, Tony. Hi, everybody. John Manijak, National Power Routing. When we first built our sewer systems, we dug a trench, we laid the pipe, we backfilled it with rock, and then we covered it up. And now we have systems that have open joints, cracks, fractures, break-in taps, and there is virtually no difference now between what we have and a French drain system. Water migration is real. Water flows along the sanitary trench and surrounds our pipes. It enters the sanitary systems through any open point. And that is why the holistic approach to eliminating I&I really works. You need to address every possible point of entry, the manholes, the main lines, the lateral connections, and the laterals themselves. The holistic approach relies on a combination of several different technologies working together in order to eliminate any source of infiltration. Cured in place pipe is a great structural solution to cracked and fractured pipe, but it is a known fact that cured in place pipe has an annular space, and many of us have lined a lot of pipe with the idea that it will completely stop infiltration. The fact is that cracks and open joints are still in the host pipe, and water will enter them. It'll travel along that annular space and then re-enter the system at the lateral reinstatements. The only way to eliminate this problem is to line or grout the lateral connection. We can seal lateral connections in lined pipe with chemical grout by using a lateral packer that you see here and a lateral sock, which is the yellow piece. The packer is pulled into place, it's lined up with the lateral connection, and both the packer and sock are inflated, and after failing an air test, the chemical grout is then pumped into the annular space and through the open joints of the lateral to the outside of the pipe where it gels and it seals. It seals both the lateral and the lateral connection, and actually it seals the annular space. An air test is then performed to verify that the pipe has been sealed. In the Naperville Crest Creek subdivision on this particular street in pink, the laterals and the main lines were leaking so badly that cured in place could not be attempted because the incoming water would have washed out the resin before it would have cured, and then we would have had a failed liner. This is a picture I took of our operator televising the main line on the very first day that we got out there. And as you can see on the monitor, the joints were leaking pretty heavily. This is a picture of a lateral from the main line showing the amount of water that was pouring in from the laterals. There was nobody home at the time, and we even looked down the cleanouts and saw that there was no water coming from the house. So all this water that you see that's pouring out was coming from the infiltration of the joints between the cleanout and the main line. most of the infiltration that we saw was located within the first 40 feet of the lateral from the main line. National Power Rodding was hired to grout the laterals using a 38-foot lateral sock. In order to prepare for the successful deployment of that sock, we set up a main line and a 50-foot lateral in our shop and practiced the insertion of the equipment and the sock itself. We determined that it would take a minimum of 4 minutes for the grout to reach the end of the sock and then saturate the ground outside that pipe. We experimented with different grout mixtures in order to give us the desired 4-minute reaction time that we wanted. We also had to be prepared for the bypass pumping out there because the amount of water that was flowing through the section was just a ton of water. Eventually we had gone out and we televised the laterals, and then lastly we had to remove all the roots and the mineral deposits from the laterals from the main line in order to accept the insertion of the sock. When they say that the first days are always the roughest, they weren't lying. These are some of the pictures of our first day out there. The lateral sock above ground is in yellow, and the gray piece that you see next to it, that's in that top picture, is the 45-foot tail, the housing for that sock. That also had to be inserted into the manhole. It was also the middle of the summer, so the outside temperatures really affected our gel time. The crews had to learn to cool down the chemicals in order to get back to our 4-minute reaction time. And once we got everything in place, we had to adjust our vacuum pumps and actually add a supplementary vacuum because the additional water in the line was preventing the sock from coming out and going into that tail. Now there were a number of lateral connections that had multiple connections or multiple laterals wired together before they connected to the main line. For these, we used a sausage packer, such as the one that you see in the third picture in the black. That was inserted through the cleanout and then pulled to each joint of the lateral. Each joint was then grouted individually. And then after all the preparation and practice, we had success. The top picture that you see is that lateral that was leaking that you saw earlier. And the bottom picture is that same lateral, now sealed. The green that you see there is a thin layer of gelled grout that can be jetted out or left in place, and the bulk of the grout is located on the outside of that pipe or in that annular space. On average, we pumped about 30 gallons of grout in each lateral, and the most grout that we had to pump was right around 90 gallons. And then finally, to complete the process, all of the mainline joints were sealed using a mainline sealer and the test and seal method. And it's never over until it's over, is it? After the grouting was completed, the main lines were then lined, and the only thing left to do was to line the manholes. And that's when Tony actually called me and said, hey, we have a problem here. The water that we stopped from coming into the lines and the laterals actually migrated to the only other point of entry, which was the manholes. So we sent the crews back out and grouted the manholes so that the lining could be completed.
Thanks, John. I think this is a good time to interrupt with an online submitted question, and I will take this moment to encourage others. As a question comes to mind, please submit now as opposed to waiting until the end. Jessica?
Thank you, Luke. Our first online question, how do you know grout will stay in the annular space between hose pipe and liner?
Well, I'll answer that one. That's actually a very, very good question. I've been asked that question many times before. When we grout, we use a an air test to confirm that the joint or the space is sealed. In order to determine the pressure at which we need to test at, we have to calculate the maximum head pressure that we would have at the level of the sewer line. So what we do is we take the level of the sewer and divide it by 2, multiply and add by 2 psi. If a sewer is, for example, 20 feet deep, we divide by 2, giving us 10, and then we add 2 psi. So we would test at a minimum of 12 psi. And if it holds at 12 psi for 30 seconds to a minute, then I know that there is no possible way that the head pressure from the groundwater would push the grout out of that annular space.
Thank you, John. So now let's do another quick poll question. In your opinion, injection grouting for municipalities is an engineered construction project, proactive maintenance practice, complementary to other trenchless technologies, short-term point repair tactic, or all of the above? Okay, looks like the majority said all of the above. Now I will go back to you, Tony.
And Tony, you're now presenter.
I'm sorry, John, Don, can you see my screen?
Hi. I'm not seeing your screen just yet, but I do see you as presenter. Let me try one more thing. Yep, you are presenter. There you go.
Okay, that dialogue just did not show up, so I was not aware I was a presenter. Grouting, when and why? When grouting, anytime you have leaking joints in your main lines or your laterals before you line. If your main line or laterals are structurally sound and you just have leaking joints you want to seal, and one of the biggest things is cost. As Don said earlier, cost and funding is an issue, and you want to just control the I&I. Why just grout? Why grouting? To control water migration. If you just line the main lines with cured-in-place pipe, groundwater will migrate to the service reinstatement and come out there. You want to grout to control I&I and, again, to control resin washout. This one's very important because if you don't control resin washout, your liner is guaranteed to fail. You're opening up a whole nother can of worms. I seem to be having some technical difficulties.
If you will just click on the screen with your cursor and then advance anyway. There you go.
There it goes. Thank you, Don. Lining, when and why? Anytime you have a structural issue, when the system is at its end of its life cycle, and why to grout? To improve the life of your assets, improve the structural integrity of your assets, and by lining the main and the lateral, you can reduce your maintenance cost. If you're just flushing on a longer time frame compared to an area where you're out root cutting or doing root control yearly. The next phases of grouting in Naperville, the city of Naperville will be, and we have started with National Power Rotting, grouting 312 service laterals from the main line to the foundation of the home. This is being done in 4 phases over 4 years. This process will include grouting the mainline connection up 4 feet with a lateral packer, grouting from the cleanout to the mainline connection, and then flipping around and grouting from the cleanout to the foundation. The cleanouts for this first phase were installed by the city of Naperville using the Backety method. And grouting is being done here instead of lining because of the services are structurally sound and our current lateral lining cured in place program is already committed to other areas. Future grouting. This is just the first phase of the 4 phases of grouting. Again, the mainline connection and the laterals from the main to all the way to from the mainline connection to the foundation of their home are being grouted. It's approximately 62 homes. Working in private property, using public money on private property, all it does is benefit the public good. Reducing I&I in private property doesn't do nothing but benefit both public and private parties. And one of the biggest things is keeping everybody educated on how handling private I&I will control many issues. Always keeping your city council and your boards involved of what's going on, talking to homeowners associations and private owners, keeping them involved also benefits the program. And with that being said, I'd like to pass it on to John.
John, you're now presenter.
All right, there we go. Thanks, Tone. Every project has the potential to be a great project. And at the same time, every project has the potential to be a very terrible project. What is it that makes the difference? It is the technicians, the inspectors, and the overall team effort that really do make the difference. Even before we mobilized our equipment to Naperville, we began the project. We began to prepare the crews by going through every phase of that project with our operators both in the office and in the shop, starting with the lateral cleaning and televising equipment maintenance, and then the experimentation with the control of the chemical grout reactions. And then finally, we practiced the insertion and the extraction of the 38-foot lateral sock and the 45-foot tailpiece. By having prepared our guys before they even went out there, we were already set up for success. Training is very important. I cannot express that enough. But experience is essential. Anybody can be taught to push a button or pull a lever. In order to be successful in grouting, well, in fact, any phase of business, you need experience. A grouting operator needs to know how to react when something just doesn't feel right or the hoses start to get grouted shut. And this can only be learned by hands-on experience. There is Grout School that's out there that's been put together by some of the manufacturers, and that'll give operators, both new and old, a chance to learn from one another. Grouters also need to go through safe practices, their certification every 3 years. This would teach the operators the importance of PPE and how to properly store and handle the chemicals. Technicians should also be 40-hour HAZWOPER trained, as most of the work that we do as grouters is performed either inside a manhole or outside or inside a pipeline. In 2012, NASCO and ICGA published a standard specification for chemical grouting to serve as a guideline for the industry to follow. In it are detailed descriptions of standard grout and packer tests and how to determine the minimum pressures at which we need to air test. There are also updated practices for mainline as well as lateral grouting. A well-informed, well-educated inspector will always be aware of what to look for in the truck and on the job site. They know the right questions to ask and the results to expect with online and on-site tests. In 2016, NASCO and ICGA will complete the construction of a new certification program designed specifically for those who want to know more as a grouting inspector. And finally, teamwork. Teamwork is key to success. When you enter into a contract, whether you're a contractor or an owner, the inspector or the engineer, you are part of a team. You are not alone. When Tony and I worked together on this project last year, we were trying to solve a very tough problem of heavy infiltration with something that really was never attempted before. It was difficult, but at the same time, it was quite enjoyable. We worked together as a team on this, and we were successful.
All right, John, thanks. I know how passionate you are about this business, and you make a great spokesman for national power routing. So let's recap what we heard today from Tony Conn and John Manijak. And while I recap, while I'm doing this, I'll encourage you once again to submit any and all questions online. I've already seen, Jessica, where we've got a lot of questions, probably more than we'll get to, but I will share with you that we'll respond to those in writing if we don't get to them in the live broadcast. But I'll tell you, forthcoming is the most interactive and most important segment of this hour, and that's the Q&A session. From a collective perspective, from both the utility owner and the contractors, here's what we learned today. First and foremost, holistic approach. Attacking all 4 points of entry is required to control infiltration. Conventional wisdom is to rehab main lines and with CIPP lining. But lining does not stop infiltration. It reallocates it to another point of entry. And because groundwater table will rise, as we heard from John and Tony, the 4 points of entry includes manholes, main lines, lateral connections, and laterals. At least up to the first 5 or 6 feet of the lateral. If you don't go 30 feet, at least get to the first initial 2 joints. Injection grouting is a soil sealing process. And it builds an impermeable matrix outside the structure. And what remains in the joint is secondary to what's outside the pipe to stop infiltration. Pipe reinstating laterals after a lining, it reintroduces infiltration. We heard that loud and clear. Sealing the annular space between hose pipe and liner at the lateral connection and the manhole termination is necessary. And I will, as Naperville discovered, Grout first may be the right approach for other municipalities for all the right reasons. Stopping active leaks, stabilizing the soil for a more durable long-term solution. Let me take a moment just to recognize Tony Conn here, because he's truly taken ownership of infiltration further than most municipal authorities. Grouting laterals all the way to the foundation is not common practice today, but I'm betting it will be. Tony, thanks for being another true pioneer. And with that, I'll turn this presentation back over to Tony, or to Luke, our moderator.
Thanks for the recap, Don. Now we will move to our Q&A session. Once again, if we do not field your individual question in this broadcast, our panel will respond to each of you with a frequently asked question document that I think you'll all benefit from. Jessica, could you read and direct the first question?
Sure, thank you, Luke. So we have a lot of questions coming in, and like we said, we may not get to all of them, but we'll answer as many as we can in the time we have left. So the first question, what's the advantage of UV CIPP over conventional inversion CIPP?
Tony, go ahead.
I can answer that. The reason being, we were looking at using ultraviolet compared to inverted cured in place or any other cured in place. One of the biggest reasons was there was no styrene smell. The outer liner seals the styrene into place. Your biggest concern when you line a sewer main is the styrene smell going into a homeowner's home. And when you're using steam or water cure, you have that huge styrene smell out in the air. So that was one of the biggest benefits with using ultraviolet compared to regular resin cured in place pipe. The other advantage of using ultraviolet is the reinforced fiberglass is stronger than the resin impregnated felt. So you can put a thinner liner in with the UV and still get, if not better, strength characteristics out of the liner.
Tony, do you recall how much more costly it is to do UV?
Again, it goes back to right now in our area, it was about 40% more. Again, it all has to do with the lack of installers out here. There's not that much competition out here. That's why we're having difficulties using the UV. From what I understand, out west and in the south, or out east and in the southwest, it's more cost comparable. And that technology is always evolving, so it should bring the cost down pretty comparative.
Very good. Next question, Jess.
Does grouting before lining extend the lifetime of the liner? If yes, how much longer?
Well, that one's...
go
ahead, Tony.
I can kind of answer that one. Actually, it extends to a point, it does extend the life of the liner. It goes back to resin washout. If you are lining a line that has heavy leaks, you're going to have, the resin's going to be washed out while it's curing. It's not going to get to true exotherm, and you're going to have weak spots in that liner. So you have potential for failure if that liner. John?
The other thought that I have is that you know, back when lining first started, they didn't have the polypropylene lining on the inside of that pipe, the plastic lining on the inside of the liner, and it was just a straight bag saturated with resin. And when that cured, the water from the sewer would run over the liner itself. And when they first started, they gave the liners about a 50-year life. I know now, since they've added that liner on the inside of the liner, it keeps it away from the constant flow of water. They extended the life of liners to, I think it's either 75 or 100 years.
It's between 50 and 100 years.
Exactly.
Now.
So, you know, so by sealing the pipe prior to lining, you would stop the water from infiltrating into that annular space that may extend the liner and may not, you know. So.
The only other thing I'll add is that the stabilization of the supporting soils behind that pipe is an asset to the longevity factor as well. Jessica, next question.
Okay, next question. John asked, or he says he's with a Chicago-based civil engineering firm. What would be their role in this type of work? How can they offer improved capabilities to be more useful to cities and contractors?
Well, I can take a stab at it. Most municipalities might not have the experience or the inspectors to inspect and or handle a job such as big as this one was. And I would believe that's where I've seen engineering firms actually take care of project management for jobs like this for smaller municipalities or municipalities that don't have the manpower for inspections or design specifications.
I will suggest that there's a lot of things that matter. Soil matters. Gel time matters. Additives matter. Changes outcomes. And temperature matters. In an engineering specification, the more you understand the assessment and the issues that are there, the more that you can dial in the appropriate kind of spec that meets exactly what's needed for that municipality, for that particular set of conditions. And that's the value engineering component that I'm excited about working with engineers coast to coast on. It's a great question, and thanks for the initiative of interested in knowing how to add and make a difference for every one of your municipal grouting jobs. If there's no other comments, Jessica, please, next question.
Okay, the next question, does grouting cause any type of chemical residue that would need to be treated by the wastewater treatment plant, or is it 100% environmentally safe?
Say the answer to that is yes. Yes, 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 meaning once the grout is injected, in 30 seconds, 40 seconds, potentially longer, it will cure. Once it's cured, it's inert, safe, and will potentially wash away with no adverse effects to the environment. And there's no structural support to this grout. It's very weak. It only has strength when it combines with soil. So it causes no adverse effects to the treatment process at all.
Yeah. As a municipality, I can testify it does not affect the wastewater treatment process at all.
And I would like to add, the grout that's left in the pipe is jetted out. We do capture it before it goes up the line as much as we can, and any grout that is left without the soil added in the gel mix, it breaks up really easy. Like Tony said, it's not a problem at the wastewater treatment plant.
Good question, though. Thank you. Jess, got another question?
Yes, this one is for Tony or John. What was the gel time for the 38-foot lateral sock, and how much grout per lateral was used on average?
Well, we went through that a little bit earlier, but I'll repeat it again. It was a 4-minute gel time. The amount of grout, the minimum that we pumped was 30 gallons, and the most we pumped was about 90 gallons. Just.
Okay, the next question, why did you choose to grout only 4 foot up the lateral from the main when you've previously used a 38-foot lateral packer sock?
Well, currently we're only going 4 foot up, just because we're only going the 4 feet up it as part of the process. It's actually a 3-point process. The main lining, the lateral packer is only going up 4 feet. It's because they can do more faster. And then we had to install a clean out anyways because the sock, there's no way the sock can make it all the way to the foundation. So we had to have the clean out there anyways. So then it was determined it would just be easier to use a push packer from the clean out, go back from the clean out to the main line and flip it over and go to the foundation. Again, the sock, we originally wanted to go 80 feet, which would get close to the foundations, but it's just not there yet, and we had to settle with a 38 foot. That's why we're at this current project, we're only doing 4 foot up with the main line. But again, we're still going all the way to the foundation because we're using the clean out and the push packer. So really the entire service lateral from the main line all the way to the foundation is being grouted. It's just in 3 different processes.
And that's not the norm. So Tony, again, hats off to you. You're taking ownership. Go ahead, Jess. We got time for a couple more questions, I think.
Okay, the next question. Grouting is viewed by many as a temporary fix. How will grouting last, and what can be done before and during the project to make sure the process is a long-term fix?
Well, that's a great question.
You know, I'm itching. Chemical grout has the half-life of 362 years. It has been tested by the EPA.
Oh, Department of Energy, DOE.
Exactly, the Department of Energy in a project where they had sealed, or they encapsulated some waste material from the nuclear plants and nuclear bombs, and it was given the half-life of 362 years, a long life. If the grout is in the ground, it will retain its moisture, it will retain its gel. If it dries out for some reason, if we're very close to the surface, we can either add an additive to it, or when the groundwater returns, the grout itself will rehydrate itself and then swell back to its original size. Don?
If we follow the NASCO guidelines and we take a look at gel times and how important they are, what's very vital to making this a long-term cure, it has the right amount of gel time to get into the soil and build that matrix all the way around the defect, all the way around that joint. And that joint will stay intact for for our generations and the next generation beyond that. Again, John is correct. The DOE gave it a 362-year half-life as long as it's in the soil. Admittedly, if you take grout in its neat form, put it in a cup, stick it in the parking lot, it will shrink. There is enough humidity in the sewer trench to make that grout perform beyond our lifetime, beyond the next generation's lifetime. And there are some testing that's going on right now to validate that beyond that of the hazardous waste containment project from the DOE that was well documented, validated after 20 years. We're now doing some deep testing and more science validation for the unique characteristics of the sewer trench. But keep in mind, the value of grout is not in the trench itself. It's outside that trench. That's where its greatest value is. I hope I've answered your question. Next question, Jess.
Okay, I think we have time for one or two more. Is there an ideal time of year to do this, to chemical grout?
One person who does a lot of business up in the Great White North in Chicagoland was probably John. John, go ahead and answer that. Can you grout year-round?
We can, just depending upon the weather. If it's too cold, where the water is going to start to freeze in our cleaning trucks, normally around 0 degrees to 20 below, that's just absolutely too cold and nobody's outside working anyhow. But up until that point, the grout truck can work. We can also, if we're only grouting manholes and we don't need the cleaning truck out there, if the lines are absolutely clean and we don't need it again, the cleaning truck, we can put the grout rig out there during the winter time in below 0 temperatures if needed.
Keep in mind, grout is 90% water. That's what makes it, the viscosity, so thin that it travels anywhere that water goes, and it's what gives it the penetration into the soil that you want. There are additives we can bring into play, like glycol, to reduce the freezing temperature of that grout mix. So we can grout in temperatures below 32 degrees. Not everybody wants to, but it's doable. One more question, Jess, and I think we better start wrapping.
Okay. Is there anything done to the manhole lids to stop infiltration into the manhole during flooded streets at high rain events?
So the quick answer to that is manhole lids is more of an inflow problem than an infiltration problem. And I don't think chemical grout is an answer to inflow, it's an answer to infiltration. John, do you have anything to add about manhole lids?
No, I think, Tony, I think you have new ones out there with the seals underneath,
yeah,
right?
I can answer that in regards to manhole lids and flooding streets. Many of our manholes, we actually have in areas that are prone to flooding streets, we have over 1,400 manhole inserts installed in under the lids. They catch any water that leaks between the lids and the frame. All of our lids are seal-type lids, and on some of the areas by the rivers and known to prone, we have lifespan lids that are locked down to the frame to stop any water infiltration and exfiltration. But we have quite a few manhole inserts installed in our manholes in all known flooding areas to stop water from leaking in between, even through a seal-tight lid, in between a seal-tight lid and a seal-tight frame.
Well, I'd love to take a little more time to talk through the difference between inflow and infiltration. What is the most painful component for you, Tony? But it's a whole subject of a whole nother different webinar. Jessica, next step.
The last poll question.
Okay.
Okay. What is the single greatest consequence of infiltration? Shorter life cycle of underground assets, reduced capacity, excess flow to the wastewater treatment plant, higher expense to the ratepayer, or sanitary sewer overflows? Take a few moments and pick one.
Looks like most of them are coming in, what, 50%? I'll go ahead and shut it down. and present the results.
Pretty close between SSOs and the excess flow.
I will close this down and
Okay, respecting everyone's time, I believe we need to begin closing this broadcast with a few announcements. Jessica will be handling PDH credits for those interested, and specific directions are included in the post survey as you exit this broadcast. Thanks for taking a few more minutes to review that. Promise documents will be sent within 24 hours from Avanti, including the NASCO ICGA operating standard, as well as a white paper entitled Role of Chemical Grouting in Wastewater Systems, How to Reduce I&I and Prevent Structural Damage. Do we have any parting comments from our experts today?
go ahead, Tony. Tony, do you have anything you'd like to contribute?
Oh, I'm sorry, you cut out there for a second. Yeah, I would just like to add, there's really no one method to fix all issues. There's many tools in the toolbox to truly control I&I and water migration. I'd also like to really thank Don and Luke and Jessica for putting together this great presentation. I'd like to thank all of the attendees for signing up and listening, and I'd like to thank National Power Lighting for the great work and cooperation they had on the first phase of this project and the phase that they're doing now.
Well, I'd like to just say thank you for everyone and their time. I hope it was both educational and entertaining for everybody. And if you want to do it again, Tony and I are going to be down in Indianapolis at the WET Show. You can see us live in person on Friday, February 19th at 9:30, and hope to see you there. Thanks.
If you're on this call as attendee, you give a darn about infiltration. It's a problem. And grouting is one of many tools, as Tony suggested. And I'm just glad to be involved in the teaching education process, to be able to use the right tool for the right circumstance and to be good stewards of the ratepayers' money. And I do think grouting comes into play nicely that way. I would like to encourage those who are truly interested in learning more, learning hands-on. There's an annual Grout school coming up in January in Houston, and you'll receive information on this as a follow-up to this webinar within the next 24 hours, including the promise documents. So this is a true hands-on opportunity. If you're an inspector, you're a municipality, you're a contractor, this is a chance to learn and experience it firsthand. Luke?
Thanks, Don. And Jessica, thank you for your assistance today, and a special thanks to all attendees. If you have an opinion about webinars as a learning platform, you'll have an opportunity to sound off in the post survey. Until next time, so long.